안녕하십니까. 경희대학교 사학과 송재령 교수입니다. 올해는 UN 세계평화의 날 40주년이 되는 해입니다. 경희학원은 그동안 세계평화의 날을 기념하는 피스바 페스티벌 국제회의를 매년 개최해 지구적 난제를 해결하기 위한 토론회장을 마련해 왔습니다. 21세기 초반의 인류 사회는 전대미문의 생태적 및 문명적 위기에 봉착해 있습니다. 경희학원은 바로 이러한 문제의식에서 현재 인류 문명의 생존과 실존의 토대를 위협하는 지구재앙 시나리오를 타개할 수 있는 지식, 정치, 의식의 전환을 위한 대담 시리즈 전환 문명의 전이 어디를 향하고 있는가를 개최하고 있습니다. 본 대담 시리즈는 모두 4개의 대담으로 구성되었습니다. 지난 9월 17일 40주년 기념식과 더불어 첫 번째 대담이 개최되었으며 이후 10월 15일과 10월 26일에 각각 두 번째와 세 번째 대담이 개최되었습니다. 오늘의 대담은 네 번째로서 본 연속 대담의 대미를 장식하게 된다는 의미에서 귀추가 주목되고 있습니다. 오늘 진행될 네 번째 대담에서는 독일 포츠담 기후영향연구소의 설립자이자 초대 소장을 역임하신 한스 요하임 쉘른후버 교수님을 화상으로 초청해 기후변화의 시대, 우리의 생존은 어떻게 가능할까? 라는 주제를 다루고자 합니다. 기후변화가 가져올 미래세계가 얼마나 참담할 수 있는지에 대해 지구인이라면 누구라도 경각심을 품지 않을 수 없는 상황입니다. 오늘날 기후변화에 따른 생태학적 위험 상황이 초래할 지구 문명의 종말에 대한 경고가 차고 넘칩니다. 얼마 전 영국 글라스고우에서 개최되었던 제26차 UN 기후변화 협약 당사국 총회에서 있었던 세계 지도자들의 연설은 이러한 위기의식을 잘 드러내고 있습니다. 한 예로 안토니오 구테르스 UN 사무총장은 각국 정상들을 향해 우리의 연약한 행성은 여전히 한 가닥실에 매달려 있으며 기후 참사의 문을 노크하고 있다라고 경고했습니다. 인류 문명을 벼랑 끝으로 몰아가고 있는 화석 연료에 대한 인류 문명의 집착 현상을 지적하면서 생물 다양성을 잔인하게 다룬 것으로 충분하고 탄소 배출로 우리 스스로를 살상한 것으로 충분하고 자연을 화장실처럼 사용하는 것으로 충분하고 자연을 태우고 뚫고 채굴하는 것으로 충분하다. 우리는 우리의 무덤을 파고 있다. 라면서 이제 더는 안 된다라고 말할 때다라고 역설을 했습니다. 구테르스 사무총장은 COP26의 성명서에 대해서도 중요한 발걸음을 내디디긴 했다. 하지만 정치적인 의지를 모은 것만으로는 크나큰 모순을 해결하기엔 역부족이다라고 지적하면서 비상상태로 전환해야 할 때다. 그렇지 않으면 탄소 배출량 제로에 도달할 확률 자체가 제로가 된다라고 경고했습니다. 안토니오 구테르스 유엔 사무총장의 이러한 격정적인 경고는 오늘 초청 대담자인 쉘른후버 교수께서 지난 2017년에 언급한 2020년까지 기후변화에 대해 구체적인 조치를 취하지 않는다면 세계는 치명적인 타격을 받게 될 것이다 라는 경고를 잘 반영하고 있습니다. 이 점에서 이번 대담에서는 쉘른후버 교수님과 함께 기후변화 시대와 지구 시스템의 임계점들이 무엇인지 논의하고자 합니다. 인류 사회는 과연 지구온난화와 이로 인한 기후 시스템의 대재앙 시너리를 극복할 수 있을까요? 이를 위해 현 인류 사회가 당위적으로 긴급하게 해야 할 일은 무엇일까요? 과연 희망은 있는 것일까요? 이번 대담을 통해 답을 찾아보는 시간이 되었으면 합니다. 쉘른후버 교수님과 대담을 해주실 분은 경희사이버대학교 미래인간과학스쿨의 조천호 교수입니다. 조 교수님은 특히 기후변화 주제를 다루는 교수이십니다. 두 분 교수님을 간단히 소개하겠습니다. 먼저 대기과학자이자 기후학자로 활동해 오신 쉘른후버 교수님은 1980년 독일 레겐스버그 대학에서 이론 물리학 박사를 받았으며 이어 1985년 독일 올덴부르크 대학에서 역시 이론 물리학으로 하빌리타치온을 받았습니다. 그 후 올덴부르크 대학과 포츠담 대학의 교수를 비롯해 또한 미국 산타페 연구소의 초빙 교수를 역임하기도 했습니다. 무엇보다도 쉘른후버 교수는 1992년 독일 포츠담 기후영향연구소를 설립해서 초대 소장을 맡았습니다. 주지하듯이 이 포츠담 기후영향연구소는 기후변화 주제와 관련해서 세계 제1의 연구소로서 현재 300여 명에 달하는 연구 인력이 기후변화 주제와 관련된 학제간 연구를 수행해가는 독보적인 연구소가 되었습니다. 널리 알려진 대로 1990년대 중반 쉘른후버 교수가 지구온난화 문제와 관련해 2도시 방어책을 제안해서 독일 정부와 유럽연합이 채택하도록 했으며 2009년 코펜하겐 합의에 따라 전 세계 국가들의 목표로 채택되는 데에 큰 공헌을 했습니다. 쉘른후버 교수는 특히 기후학적 티핑 포인트 이론의 독보적인 전문가로서 지구온난화의 지속이 초래하게 될 인류 문명의 끔찍한 결과에 대해 경고해 왔습니다. 쉘른후버 교수는 기후학적 위기에 관한 발견과 경고를 유럽을 넘어 글로벌 공동체의 사회, 경제, 정치 영역들과 공유하기 위해 다양한 역할과 활동을 펼쳐왔습니다. 이에 따라 2007년 독일 환경상을 수상했고 2011년에는 독일인 최초로 볼보 환경상을 수상했으며 2017년에는 녹색 지구상을 수상한 바 있습니다. 주요 조서로는 지구 시스템 분석과 제2의 코페르니쿠스 혁명과 인류세 시대의 지구 시스템의 궤적 외에 250여 편의 연구 논문을 발표했으며 50여 권의 저서를 출간했습니다. 대담을 이끌어 가실 조천호 교수님은 대기과학자입니다. 조 교수님은 연세대학교에서 대기과학 박사를 받았으며 국립기상연구소 연구원으로 재직하면서 예보, 기후, 지구감시 및 지구 시스템 분야를 연구했으며 미국 해양대기청 지구시스템과학원 탄소순환그룹의 연구원으로 근무하기도 했습니다. 그리고 국립기상과학원의 원장을 역임했습니다. 2019년 이후 현재까지 경희사이버대학 미래인간과학스쿨 교수로서 기후변화 주제를 전문적으로 연구하고 있습니다. 시민단체인 변화를 꿈꾸는 과학기술인 네트워크와 기후위기 비상행동에서 활동하고 있으며 2017년 이후 현재까지 국내 여러 주요 일간지에 기후변화에 관한 고정 칼럼을 연재하고 있습니다. 저서로는 파란 하늘, 빨간 지구, 부제로, 기후변화와 인류세, 지구 시스템에 관한 통합적 논의, 그리고 기후변화의 과학과 정치를 비롯해서 8권을 출간했으며 수십 편의 연구 논문과 보고서를 발표했습니다. 오늘 대담은 두 교수님의 자유로운 토론을 중심으로 진행됩니다. 본격적인 대담에 앞서 약 20분간 쉘른후버 교수님의 강연을 듣고 강연이 끝난 후에는 곧바로 조천호 교수님께서 대담을 이끌어 주시게 됩니다. 자, 그럼 한스 요하임 쉘른후버 교수님의 강연을 청해 듣도록 하겠습니다. 감사합니다.
So, good afternoon to South Korea. Professor Lee, Professor Cho, thank you very much for the kind introduction. And I will try to share my screen with you. Let me see. So I hope you can see it. Is that right? Okay, so I will start with my lecture now and hope that the technology will work right. Can I get any feedback whether the screen is shared with you, whether you can see it? Thank you very much. And we have the interpretation. So I'll go ahead. So the title is The Climate Challenge and the Great Transformation. So on the one hand, as has been said already, we have a major challenge, and I tried to lay it out to demonstrate what is really at risk and what is at stake. And the second part will be, what do we need to do in order to still avert a major climate crisis? And I will also come up with a specific solution I've been thinking about for several years now. And I think there is something what you might even call a silver bullet solution. But let's see. So we just had, and this was discussed in the beginning, we just had the so-called COP26 in Glasgow, and a number of interesting decisions were made. You can see some of them dealing with methane, phasing out of coal globally, which is a major challenge, and so on. But we will discuss this later on. What steps have been made? Are they sufficient? And on what trajectory are we actually right now? And of course, a major reference to everything is the report. And you see a very prominent member from South Korea in the IPCC, the report on 1.5 degrees. Because in Paris, there was, as an international agreement, an international law, the decision to keep global warming well below 2 degrees, but there are ambitions as an aspirational goal, try to keep global warming, to limit global warming to 1.5 degrees, which is very, very hard to achieve. And actually, based on my expertise, we will not hold that line, but we actually can see it as a long-term reference point and maybe come back to even less than 1.5 degrees later. So I introduced actually as a member, together with colleagues, in the third assessment report of the IPCC, which was published in 2001, the so-called burning embers diagram. And that was the idea, if you look just to the right-hand panel, the idea was in the third assessment report, you see in the right panel, you see on the left column, third assessment report, TAR 2001. The idea was, at what global warming level do we have major nonlinear changes in the Earth system? We called them large-scale singular events, now better known as tipping points, or the activation of tipping elements. And you see we had, because you do not have precise analysis, or we don't have them yet, we said, let's use a color coding in the sense that if you are in the white region, there is no major risk. If you turn yellow, you see here in the third assessment report, it was between 3 degrees and 5 degrees when you are entering a very difficult zone. And if you are in the red zone, if the red color appears, then you can actually expect that a tipping event will happen. And now you see, and this is really remarkable, how the color has changed over the various assessments. So in the AR5, the fifth assessment report, you see that the red color has come down already. And in the 1.5 degrees report, which is now our reference point, 2018, you see that already below 1 degree, the yellow color appears. And if you are beyond 2 degrees, it's turning red already. Yeah? And now if you compare this with the Paris Agreement, 1.5 degrees, you see the broken line, and the full line, 2 degrees. You see, yes, we have to actually stop global warming between 1.5 and 2 degrees. Otherwise, we will run into uncharted territory and major risk of tipping events. Now, in a way, it's all based on this analysis. So I introduced this map of the tipping elements in the Earth system in a lecture I gave at Oxford University in the year 2001, actually. And you see there the vital organs of the planetary system, of the planetary body, if you like. So the big ice sheets, of course, the big ecosystems like the Amazon rainforest. But for in the short term, maybe even more important, the circulation patterns in the ocean, that is the so-called Atlantic thermohaline circulation or Gulf Stream. But in the atmosphere, it's the so-called jet stream, which is a band of high-speed wind going from the west to the east, about 10 to 12 kilometers above ground. And this is organizing on the northern hemisphere. Our weather system is also responsible for extreme events. You see here Greenland Ice Sheet. I mean, the amazing thing is that you had in the last years the loss of 1 million tons of ice per minute, actually. So the Greenland Ice Sheet, its stability is at stake, probably beyond 2 degrees. It will be completely destabilized and will collapse over hundreds and thousands of years, of course. I mentioned already the Gulf Stream. Colleagues of mine have shown that the current Gulf Stream is the weakest in the last millennium. And I mentioned already the jet stream. Now you see, these are real data provided by NASA. You see how this jet stream is moving, it's meandering, it's building, forming big bulges. And actually the animation will stop and when you will see a big so-called Rossby wave. These are the variations of the jet stream over the North American continent or subcontinent. What you see here is that the jet stream is pushed very far to the north. So hot and dry air from Mexico is moving up to Alaska, actually. And this is, of course, an extreme weather event. Now, if this Rossby wave would move across the Atlantic, move away within a few days, it would be fine. But actually, we have now seen over the last decades that these Rossby waves become stationary for many weeks. So you see, for example, here in 2018, on the right-hand side, we had this problem that the Rossby wave stayed stationary over Central Europe, for example, for 6-8 weeks or longer. We had forest fires in Scandinavia. And on the other side of the Atlantic, you had a cold spell, a Rossby wave reaching far to the south on the east coast of the United States, bringing about flooding, chilly weather, and so on. And according to our analysis, we published a major paper on that in 2013. The jet stream will become more wiggly in the future, and the Rossby waves will become more stationary. That means we will have a new regime of extreme weather events. Amazon rainforest, because of human intervention, forest fires, and so on, we estimate, and global warming, changes in the precipitation patterns. We assume that the tipping point can happen at 2.5, 3 degrees warming, something like that, if there is more human intervention even earlier. So all together is assembled. Everything is assembled in this chart. That is a paper we published in 2016 in Nature Climate Change. And this is a major chart, and I will dwell with it for a minute because it's very important. What you see here, the horizontal line is the time axis. So you can go back to the last ice age, the minimum of temperature, 20,000 years before present. And you see the wiggly line is the global mean temperature. So it was just about 3 degrees colder at a global scale at the time when in the Holocene 11,000 years ago, we emerged for the ice age. And when you see the climate was more or less stable over the last 2,000 years, and on the right-hand side, you see this colored fan. These are the scenarios. Where do we go, actually? If everything goes right, we stop That's the green line. We stop below 1.5 degrees. But there are intermediate scenarios. Unfortunately, currently, we are still more or less on the dark red line. That would mean we would have in the year 2500 something like 8 degrees warming. And the Paris range is this horizontal gray bar. You can see the Paris corridor. And now the really important message is, when will the various tipping elements be activated? And you see we have again this color coding, yellow, red, and so on. And you have a number of tipping elements which could be activated already in the Paris corridor. So for example, you see in the left-hand bar, in the left-hand box, you see the coral reefs will probably die back already between 1.5 and 2 degrees warming. The West Antarctic ice sheet, some parts have been activated already. You see Greenland and so on. So the Paris corridor is actually something like a firewall. It can exclude some major events. You see on the right-hand side, the collapse of the thermaline circulation, the collapse of the Amazon rainforest, and most importantly, the collapse of the Eastern Arctic ice sheet. If that becomes destabilized, we will have global warming that would be the range 6-7 degrees, and in particular, we would have sea level rise of another 50 meters. So the message is the following: if we hold the Paris lines, if we keep global warming to 1.5 to 2 degrees, some tipping events will already happen, but the worst of them will be avoided. So the Paris Agreement is a firewall against disastrous global warming. Now that's the story, and just go on here. The paper, which has become quite famous now on trajectories of the Earth system in the Anthropocene, which were published in 2018 in Proceeding of the National Academy of the United States, that tells us that actually something could go wrong in a very intricate way, because the various tipping processes could conspire and could bring about something like a major destabilization of the global environment beyond 2 degrees. And I give you just one example how this interaction of tipping elements could happen. We have now the Arctic warming 3 times faster than the rest of the planet. This has a major implication for the surface melting of the Greenland ice sheet. Now, if more fresh water goes into the North Atlantic, this in a way is destabilizing the thermaline circulation in the North Atlantic, but also the jet stream. The jet stream, again, as I explained, has a major impact on extreme events, for example, heat waves in Siberia. That could affect the permafrost, could accelerate permafrost melting. This in turn will create forest fires, and the Arctic warming would be accelerated in turn. So it's a vicious circle that could be created. Now, we will discuss it later. The science is in no way settled about this. Many things are speculations. We have indication from historical data, but it is a risk we have to explore in the future. So let me share this with you, which is a very important finding also. Where does the extra heat go? And actually, most of it goes into the ocean, more than 90%. Just 2 or 3% into the atmosphere. And that is a major challenge, because the oceans accumulate the heat for millennia, actually. So even if we stop CO2 emissions and methane emissions, and the atmosphere becomes more balanced, there is still this accumulated heat over the last 2 centuries, and the oceans will actually exhale this heat over millennia. So global warming will only stop if the ocean come into equilibrium again. So we have a legacy of the Industrial Revolution that will linger with us for many millennia. So we have to stop emissions immediately. Is this how our civilization ends? Hopefully not. What can we do about it? And I'll give you just a few hints. We have published a paper in Science in 2017, a roadmap for rapid decarbonization. The idea is to bring down emissions to half them actually every decade now, and to virtually become decarbonized by 2050 globally. That means the industrialized countries actually have to decarbonize by 2040 or 2045 at the latest. Now, this will happen through the switch to renewable energies. On the left-hand side, you see what type of renewable energy will win in the end in the various countries. Wherever you see the yellow color, it will be photovoltaics. That includes South Korea, for example, and of course, most of the global South. There are just a few countries where wind energy will be the dominant source. And in green, you see countries like Germany, where you have a mix of wind energy, solar energy, hydroelectricity, and so on. My final argument, where I will spend a few minutes, is decarbonization is important. We have to get rid of fossil fuels in our global economy. But at the same time, we will only be successful with the Paris Agreement if we protect the existing biospheric carbon sinks, that is in particular the forests of the world, and we have to create additional artificial carbon sinks. And how this can be done, I will show you now. I can refer again to the IPCC report, where on 1.5 degrees, there has been a lot of arguments about negative emissions, so creating additional carbon sinks, where we remove by management actually carbon from the atmosphere. And the main hope was that it will be provided by BECCS, bioenergy with carbon capture and storage. I'm very skeptical about it. What would in particular mean you take biomass, you convert it into biofuels, you sequester the carbon by sort of filtering out the CO2 from the smoke and so on. I'm skeptical about it. I think there's a better way to do it. And first of all, of course, we have to protect the world's forests. We have to stop deforestation in the global south, of course. We have to plant new trees, and actually there is this paper by Bastard et al., who showed that on degraded land you could actually reforest about 900 million hectares, which would provide a major carbon sink. And it's the precondition for using timber and bamboo for our built environment. So I go through that quickly. The elephant in the climate room, and that is my main argument when it comes to carbon sinks, is the built environment, the elephant in the climate room. It's responsible for about 40% of the global emissions by constructing buildings, by maintaining and operating buildings, and by destroying them again. And the built environment is responsible for more than 55% of the waste, and it requires about 70 to 80% of the resources as well. So if we transform the built environment in line with the Sustainable Development Goals, then we will also win the war against global warming. We have published a paper on that, and the basic idea is if a tree grows, it absorbs CO2 from the atmosphere. Now, if you take the wood from the tree, convert it into timber, and use it for constructing buildings, and these buildings will last for several centuries when you have created a carbon sink. And the major idea is buildings as a global carbon sink, that you convert our cities where you have now been constructed from steel and concrete into, urban forests, if you like, if we really convert them into organic material-based construction when you have created an artificial carbon sink. And of course, that applies in particular for the cities that still have to be built. And I show you just as a demonstration, we have calculated if for additional 2 billion people who will populate this planet by the year 2050, if you build most buildings, 90% from concrete and steel, on the right-hand side, you see a gigantic extra emission of carbon, more than 70 billion tons of CO2. But if you do it from wood, from timber, from bamboo, and so on the one hand, you avoid almost all of these emissions on the right-hand side. You see the emission bar is shrinking heavily, but in addition, you store 75 billion tons of CO2. So altogether, this is already 30 to 40% of the remaining carbon budget we have for the 1.5 degrees. And this can be done through what I call a forestry construction pump. So you plant trees, you cut them, use them for timber production, you immediately replant the trees. That is the forestry pump. And the same with the built environment. You build from timber, but once you don't use the building anymore, you dismantle it and build from the timber new constructions. And this all together helps to clean the atmosphere from CO2. This is in the tradition. So I helped to create a new Bauhaus movement. That's the old Bauhaus that was actually pioneering construction in the 20th century. The Bauhaus was created by Walter Gropius and others in 1919 in Germany, in Weimar, and then more or less set the stage for construction in the 20th century. The remarkable thing was that it was an integrated approach. I wanted to bring together architects, designers, artists, carpenters, technologists, and so on, entrepreneurs together to build a new environment actually for the masses and not for the elites anymore. So it was also a project of social progress. And now I've helped to create now a new movement. Ursula von der Leyen, the President of the European Union, has last year in a State of the European Union speech announced a new European Bauhaus, which will focus on three things. It will focus on sustainability, so it will explore the use of biomaterials in future construction. It will be inclusive, so how can we provide decent accommodation for every person on this planet? And it's also about beauty. It's about aesthetic values. How can we build our cities in a much more beautiful and more humane way in the future? Because after the Second World War, and it happens in Germany, in Belgium, in Korea, in Japan, in the United States, everywhere, we have built mainly ugly, dysfunctional buildings, skyscrapers, which are not at the human dimension, if you like, and this has to be changed. So the idea is to, in one way, to protect the climate by building a better environment and providing better accommodation for humanity. In my view, this is really a silver bullet. So I leave this solution with you. And in Germany, I have created as a charity and not for-profit organization, the Bauhaus der Erde, Bauhaus Earth. and that has taken off now, and it is actually something that will have a major impact on the new German government. They just announced that a ministry for construction and accommodation will be created now, and it hopefully will be very much inspired by the Paris Agreement and by the quest for climate solution. So with this I end, and I thank you very much for your attention.
네, 쉘른후버 박사님으로부터 우리가 좋은 이런 이제 발표를 아주 인상 깊은 이런 발표를 이제 들었습니다. 오늘 제목처럼 기후 위기로 인한 도전과 이제 담대한 전환이라고 하는 이런 제목으로 말씀을 해주셨고, 또 기후 위기로 인한 도전, 즉 오늘날 그 인간이 배출하는 온실가스만이 이 지구 기온을 결정하는 것이 아니라 바로 지구는 양의 되먹임이라고 하는 걸 통해서 스스로 이 기후 변화를 증폭을 시킬 수가 있고, 그래서 이제 파국까지 갈 수가 있는데요. 바로 이러한 파국의 그러한 시점을 우리가 이제 티핑 포인트라고 하고, 또 이 티핑 포인트는 회복이 이제 불가능한 위험이고, 그러기에 오늘날 우리 문명의 이러한 실존적인 이제 위협으로 우리에게 다가오고 있습니다. 바로 이 문제를 이제 해결을 하기 위해서는 바로 이러한 에너지 시스템, 그 다음에 우리의 이러한 공간의 이러한 문제에 있어서 완전히 이러한 전환, 담대한 전환을 할 때만이 바로 이제 이런 문제를 해결할 수 있다라고 하는 이런 취지의 이제 강연을 우리가 함께 들었는데요. 오늘날 이 기후 위기를 이제 해결을 한다라고 하는 거는 그래서 이러한 자연 과학뿐만이 아니라 이제 사회과학까지 포함을 하는 우리가 다학제적인 이러한 연구가 필요하고, 바로 이러한 연구를 하는 세계적인 그런 연구소가 포스탐 이제 기후 영향 연구소입니다. 이 포스탐 그 기후 연구소를 이제 설립을 하셨고, 지난 1993년부터 2018년까지 그 연구소장을 이제 쉘른후버 박사님께서 이제 맡아오셨는데요. 그러면 제일 처음 질문으로다가 이 포스탐 기후 영향 연구소의 이런 설립 목적, 그 다음에 가장 최근에 그런 핵심적인 활동이 무엇인지에 대한 거를 첫 질문으로 하고자 합니다.
That's very interesting, actually. My good friend Klaus Hasselmann, who received the Physics Nobel Prize just a few weeks ago, together with Manabe from Japan, you know, they were leaders and pioneers in climate modeling. He was actually the head of the founding committee for the Potsdam Institute. So I met them in 1991. It was just after Germany became reunited, which is something, in a way, a role model for Korea, I hope, in a way. And so the idea was, climate modeling was established at the time, but nobody had ever thought about the impacts of global warming. What will it mean if the Earth really warms by 2, 3, or 4 degrees? And what can be done about it, actually? What are the solutions? How can we avoid it? And nowhere in the world was any institute looking into that. Why? Because at that time it was still hotly debated whether global warming is real at all. Although already in 1896, Svante Arrhenius, the famous Swedish scientist, had already calculated the greenhouse effect. That is the famous paper dating back more than a century. But anyway, Klaus Hasselmann and a few other prominent scientists from Germany said, we need to establish an institute that really looks into the consequences of warming. And of course, the idea was that if we see that the risks are too high, to foster all types of measures in order to avoid global warming. So I was asked, I was at that time a young physicist working at the University of Oldenburg, that just received a chair, a professorship, full professorship. And I was asked to think about a concept for that. And I said, the only way you can address this is in an interdisciplinary way. You have to think of how will the extreme events pattern change? What will it mean for agriculture? If agriculture is suffering from global warming, what will be the best measures against it? But if you do it just in a brute force way, you may have even more emissions from methane, for example, and so on. What will you do about extreme events in the hydrological system, for example? Is it enough to just build dikes? What will you do for coastal protection and so on? And the question is, will the measures in a way accelerate global warming, or can you find ways to adapt to global warming that will at the same time mitigate global warming? So in the end, it's a very complicated systems analysis you have to do. And on that way, I in particular discovered that you have to look at the non-linearities. So are there critical thresholds in the climate system which you must not transgress? And this, in the end, I pursued that for many years. This, in the end, is the ultimate justification for a global temperature limit, which in the end materialized in the Paris Agreement. So it's been a long, long journey, but it was a journey of systems analysis. It was a journey of integrated, interdisciplinary analysis in the end of the entire Earth system. So we have come a very, very long way.
예. 굉장히 아무튼 이런 다학제라고 하는 이런 연구소를 갖고 있다라는 게 굉장히 이제 부러운 요소도 되는데, 그다음 우리 쉘른후버 박사님의 좀 개인적인 이런 질문을 한번 해볼까 해요. 우리 쉘른후버 박사님께서는 그 이제 원래 그 복잡계 이론 물리학자인데 어떻게 이 기후 변화의 이런 티핑 포인트라고 하는 여기에 관심을 갖게 되었는지요?
Yep, precisely through my work in complex systems, nonlinear dynamics. You know, I started as a fundamental scientist. I worked on quantum mechanics in particular. And when in the late 1970s, a new field of physics emerged, which was, by the way, also honored by the Physics Nobel Prize this year. And it was called chaos science at that time. Now, it has a more respectable name now. We talk about the theory of complex systems, nonlinear dynamics. So when I went to the United States, I worked at the University of California. This was a field just emerging, and it was about, in particular, nonlinear effects. So when I came back to Germany and ultimately founded the Potsdam Institute, I thought, well, most of the analysis done so far, in particular by the economists, were more or less just linear analysis. In a way, you just draw straight lines, and when you ask when will the costs of an effect be bigger than the costs of avoiding the effect, so that is the conventional linear paradigm of economic analysis. And I thought, well, the world is full of non-linearities, actually. Water is freezing at 0 degrees. That is a phase transition, or systems become destabilized if you tip them at a certain point, for example. So I thought this entire field of complexity and nonlinearity has to be considered when we deal with global warming. Why? Because if you look back in climate history, it's full of nonlinear events. For example, the thermaline circulation, the Gulf Stream collapsed many times in the Earth system, and the so-called Heinrich events. So it's very important, actually. It's very important that you look at these nonlinearities. So I used my full knowledge and my full analysis of complex systems and applied it to the Earth system, to global warming, which was more or less for the first time, really. And when you immediately go into this field and find where are, if you like, vital organs in the Earth system, what will happen to the Greenland Ice Sheet, for example? And here I just give you a nonlinear effect. You know, the Greenland Ice Sheet is about 2,000 to 3,000 meters high. Now, if surface warming happens, when the surface is moving to a lower level, of course, where it is already much warmer. And so it's an accelerating process. The deeper you go, the faster the acceleration. The deeper you go, the faster the melting happens. And you cannot stop it anymore once it is created. And so the climate system is full of nonlinear effects. And that I introduced in particular in the debate for the third assessment report when I was a coordinating lead author for Working Group 2. And this has become ever more prominent the more people have worked about it. And now we see, I showed you one of his charts, that actually the ultimate justification for the Paris Agreement is we need to avoid critical thresholds. We must avoid that some of the vital organs of the planetary system are tipped into a new state or even tipped into annihilation.
네, 지금 답변 중에 이제 그 어떤 경제적인 선형적인 이러한 비용 편익의 이런 어떤 위험 대응이 아니라 바로 이러한 비선형적인 이런 이제 대응이 필요하시다라고 하는 이런 측면에 이제 말씀을 해주셨는데, 그런데 2018년에 그 노벨 경제학상이죠. 예일 대학 교수인 노더 하우즈가 이제 그 노벨 경제학상을 받았는데, 그 이분은 그 지구 가열이 한 3도 내지 뭐 4도까지 이렇게 올라간다. 바로 이제 그 3, 4도가 이제 경제적 그러한 비용 편익에 있어서의 그런 최적 수준이다. 이런 이제 주장을 하시잖아요. 그런데 우리 지금 과학에서는 우리가 1.5도 이제 2도라고 하는 게 이제 위험하다라고 그렇게 이야기를 하고, 이러한 측면에 우리는 어떻게 이해를 해야 되는 것인지 이러한 차이가 있는데, 예.
Okay. So you're talking about Bill Nordhaus, is that right?
예, 노더 하우즈 예, 경제학자를 말하는 겁니다. 예.
Nordhaus, who received the Nobel Prize in Economics. Now you know that the other contender for the Nobel Prize in Economics was Mr. Weizmann, and who had this theory about the fat tails of the effects, the economic effects. I had many discussions with Bill Nordhaus about this, and I think in his entire theory, he does not really appreciate and he does not really include the nonlinear dynamics. There is no economic model in the world, integrated assessment, which is fully incorporating the nonlinear dynamics. So in a linear world, if the climate damage is just proportionally increase with global warming, the Nordhaus analysis is correct. But if you include the non-linearities, you see that you have to come down with the optimal temperature. And actually, colleagues of mine of the Potsdam Institute have done such an analysis, and they find that you definitely have to be below 2 degrees. They even said, if you consider the cost of mitigation as well as the damages avoided, 2 degrees is the optimum point. And I'm sure economic thinking will progress and it will advance. And in the end, it will find, yes, 3 to 4 degrees is just too high. It is actually destabilizing our civilization.
네. 그다음에 이제 우리 과학에서 우리 그 티핑 포인트를 이제 지구가열 1.5도, 이제 2도 뭐 그렇게 이제 이야기를 하고 있는데, 이게 이제 하나의 값이 아니라 이렇게 이제 2개의 값으로 제시가 되고 있잖아요. 이 1.5도, 2도라고 하는 거를 우리가 이 티핑 포인트의 어떤 불확실성의 그런 어떤 폭 정도로 우리가 이해를 해야 되는 것인지, 그러한 측면에 질문을 드리고 싶습니다.
No, you're absolutely right. We have many uncertainties here. First of all, the first question is there something like a global tipping point? And this was discussed in this paper about the trajectories of the Earth system in the Anthropocene. So is there a point, say 3 degrees warming, where the cascade of tipping events in a way is setting into motion a sliding down a slippery slope of the Earth system, and could bring us into a sort of hothouse Earth with 6, 7, or 8 degrees warming. I personally think the risk of that is very low. It's maybe 2 or 3%. On the other hand, would be the end of our world. So 2 to 3% is still very high. If you would enter an airplane and the pilot would tell you you will have a crash with 2 or 3% probability, I don't think you would enter the airplane. So we talk about the fate of humanity. No, but actually there are many tipping points in the system. So the West Antarctic ice sheet will melt much earlier than the East Antarctic ice sheet, for example. So you have a series of tipping events, so to speak. Some of them will happen simultaneously, but some of them will happen very early. For example, the loss of tropical reefs will happen already at 1.5 degrees, while the last in line will be the East Antarctic ice sheet. If that starts to melt, I mean, sea level will rise by 50, 60, 70 meters. That would be the end of all our coastal zones, so to speak. So you're right. There are two things. One of them is, even if we would know the precise tipping point temperature, they are at different temperatures. And this other thing is the uncertainty, because the research on tipping points has started much too late, in my view. We should have done this already 20 years ago. And, still people debate, is there such a thing as a tipping point for the Greenland ice sheet? If you look back in climate history, yes, it happened many times. I'm absolutely convinced. But we have actually dragged our feet for too long. We have not started with this research. And that's why the economists cannot incorporate it in their models, of course. The physical basis for that has been neglected for a long, long time, actually.
네. 그다음에 이제 그 쉘른후버 박사님께서 2001년도에 IPCC 이제 주 저자로 이제 참여를 하셨고, 그때 이제 티핑 포인트를 집중적으로 이제 다뤄 주셨는데요. 오늘날 이 IPCC 이제 이 보고서가 이제 각 나라의 이제 기후 과학자들이 모여서 이제 합의를 하는 과정에서 이 보고서가 이제 만들어지다 보니까, 물론 신중하다라고 하는 이런 장점도 있지만 굉장히 이제 보수적이다라고 하는 또 이러한 이제 이야기도 좀 듣고 있어요. 이 오늘날 우리가 IPCC에서 이 합의했던 그러한 수준의 이러한 우리가 지금 놓치고 있는 그러한 위험이 발생할 수가 있는 것인지, 혹시 있다면은 어떤 요소들이 그러한 것인지 이야기를 해 주실 수 있는지요?
Yeah. Now, first of all, the IPCC is not doing research. They just can provide the assessment on the basis of published peer-reviewed articles, of course. And as I said, since the field of tipping points has been neglected for a long time, also because we didn't have the data, we didn't have the models, complexity science had to advance and had to progress first. We have not so much literature on that as we have on very simple effects like how global warming or local warming will affect the harvesting of certain grains, for example. We have a much wider literature on that. So inherently, by construction, if you like, the IPCC reports are conservative. And they are, in my view, lagging behind the front line of research by at least 10 years or something. That is the problem. And this is a problem because it might mean that we are approaching red lines very rapidly, actually, without having early warning signals. And this is a problem. The question is whether you want to adopt as a politician the precautionary principle, or you just want to do optimal management. Optimal management would mean Economists do precisely that. You calculate the cost of mitigation, the cost of adaptation, and so on, the damage costs, of course, and then you try to find an optimal strategy. But if you do the precautionary principle, when you try to protect humanity even against 2% probability events, because they could be the end of our civilization, but then the costs would be, of course, much higher, and it can turn out that you protected humanity against something that never happened. Somebody needs to take the responsibility for that. I would rather be on the precautionary side, but governments tend to do optimal cost analysis. That is a problem.
그리고 지금 현재 이제 그 티핑 포인트, 이제 위험성에 대한 이러한 부분들을 이제 계속 우리가 강조를 하고 있는데, 지금 작년, 그러니까 2020년도에 지금 이미 산업화 이후에 지금 1.25도까지 지금 지구 평균 기온 상승이 1.25도가 지금 상승을 한 이러한 상황이 있잖아요. 지금 1.5도가 우리가 티핑 포인트라고 했다라고 하면 이게 이제 거의 다가선 이러한 이제 상황이 되었고, 이러한 상황 속에서도 우리는 과연 이 1.5도라고 하는 거를, 이런 기온 상승을 우리 인류에게는 제어할 수 있는 능력이 있다라고 보시는지요?
Now, that's a very important and a very deep question. Actually, I was member of the German delegation in Paris in 2015, when, as was said rightly, the 2009 Copenhagen Accord was implemented in a way to have international law to keep global warming below 2 degrees. But at that time, in particular, the small island states in Paris came up with a more ambitious level of keeping global warming below 1.5 degrees. Now, in terms of climate impacts to be avoided, I mentioned the coral reefs, but also in terms of sea level rise, 1.5 would be, of course, much better for our civilization than 2 degrees. Unfortunately, I see a very, very slim chance to keep global warming between 1.5 degrees. If you just look at the latest IPCC report, I showed the various scenarios. If you look at the aerosol hiding effect, we have still so much ordinary air pollution that it is masking the CO2. I think if we would get rid of the air pollution, the aerosols, that would mean already another 0.5 degree of warming, for example. So there are many reasons why we cannot hold the 1.5 degrees line. So I think we need a more holistic approach to it. I think we should do everything, according to my own analysis, to keep global warming below or near 2 degrees. I think beyond 2 degrees, many things will happen which we cannot undo later, so irreversible things. But 1.5 degrees, I think we will overshoot also permanently in 20, 30 years from now. But I showed you a possibility to come back to 1.5 degrees if we would create global carbon sinks, and the construction sector would actually provide an opportunity for that. So my scenario for the future is humanity should do everything to keep global warming near 2 degrees, and then start now already measures to restore the global climate to 1.5 or even less in the decades to come. But this is a very, very long shot. I guess that only in the next century we will restore the climate to 1.5 or even 1 degree, because actually, like Jim Hansen also said famously, I think 1 degree warming would probably a level which is most benign for global civilization.
네, 1.5도 우리가 티핑 포인트에 대해서 이제 굉장히 절박한 상황임에 대해서 이제 말씀을 해주셨는데, 그래서 우리 쉘른후버 박사님께서는 언제나 그 비선형성을 갖다가 오늘날의 이 비선형적 위험을 갖다가 대응을 하려면 우리가 비선형적으로 또한 대응을 해야 된다, 이런 말씀을 이제 해주셔요. 그래서 오늘날 다시 말해서 이제 이 기후 티핑 포인트를 이제 막기 위해서는 바로 이제 사회적인 이제 티핑 포인트가 이제 필요하다라고 하는 것이죠. 그런 측면에서 이 기후 위기라고 하는 거하고 이 사회 경제의 이 연결성의 이런 티핑 포인트 관점에서 우리는 어떻게 이해를 해야 된다라고 보시는지요?
Now, thank you very much for mentioning this, because if you look at the complexity and nonlinearity of the climate system, you should also look at the complexity and nonlinearity of the social system, which in the end has to manage global warming. So we published a paper last year also in PNAS, Proceeding of the National Academy, on social tipping points, which has become very prominent and has been referred to many times already, where we came up with 5, 6, 7 ways how nonlinearity could help us in accelerating, protecting the climate, and even restoring the climate. And one example is very popular now, the youth movement, which Greta Thunberg started, Fridays for Future, which is, at least in Europe, very prominent, not so much in the United States, probably not so much in South Korea and Japan, but in Europe it's very prominent. And it has helped, for example, to change the mood and to change the mind of most European governments. So we have in Europe now the Green Deal, European Green Deal, which was announced by Ursula von der Leyen. I mentioned her last year, which means Europe wants to become the first climate neutral continent on Earth. And that was very much inspired by the youth movement, for example. Other things are the rapid acceleration of renewable energy. And I think another tipping point, a social tipping point, could be that we consider to build all our cities in the future, all our infrastructures, from bio-based materials. As I mentioned, you now can, using cross-laminated timber, you can build skyscrapers from timber, actually. And some of them are being built already in Vienna, in Norway, in Dar es Salaam, in Tanzania. In Japan, they plan to have a 100-story timber skyscraper, for example. Now, once people see that this is feasible, it's even more comfortable and it's nicer when building skyscrapers from concrete and steel. I think it will start a social movement, really. So it will tip the construction market actually towards bio-based material. So in the end, it's the power of ideas. It's the power of inspiration. The biggest non-linearity in the world is our fantasy and our imagination. And we have to harness it for building a better world.
지금 슐렌후버 박사님께서는 우리가 과학자일 뿐만이 아니라 독일의 총리, 그다음에 유럽 연합 의장에게 이 기후 위기에 관련된 이런 자문관의 이런 역할도 하고 계시는데요. 그러한 측면에서 제가 이제 궁금한 건데, 이 서유럽 이 대부분의 국가들이 이런 정파성, 그러니까 보수냐 진보냐 이제 상관없이 기후위기 대응을 국가의 그런 핵심 의제로 이제 다루고 있잖아요. 도대체 이 서유럽에서 이러한 여건은 어떻게 이제 만들어질 수 있는지 그것이 궁금합니다. 예를 들어서 이제 미국 같은 경우는 이게 정파성으로다가 완전히 이제 기후위기를 대응하냐 안 하냐 이렇게 싹 나눠지는데, 어떻게 서유럽은 그렇지 않은가에 대한 여기에 대한 질문입니다. 예.
Okay, it was not me alone, of course. I had some influence and I had some chances actually to talk to political leaders. Yes, that's true. I think in Europe, the secret is that scientific evidence and academic research is held in very high regard still. You know, the Enlightenment started in Europe, of course, in the 17th century, based on, you know, great minds, Newton and Leibniz and Immanuel Kant and Descartes and so on. When you had, after the French Revolution, you had this idea that even society is ruled by scientific evidence. And this went up and down, but in the end, you have this legacy of Enlightenment scientific evidence in Europe. And in the various cultures of Europe, whether you go to Italy, to Russia, to Sweden, to Germany, to France, anywhere, you have this legacy of the Enlightenment. So when you want to deal with climate change, you must not listen to conspiracy theories or things like that, as many people do, unfortunately, in the United States. You have to ask the famous academies, the Royal Society, the German Leopoldina, and so on, the Academy of Athens. You have to ask them, what shall we do? And I found that as a professor of climate science, people are willing to listen to you, actually. And I hope the same situation is true in South Korea. I also found it happening in Japan, for example, when the Japanese government, after the terrible accident of Fukushima, when they developed a new energy strategy, I was invited to give a lecture in the parliament in Tokyo, and people listened to me, and I gave advice to the committee. So in the end, the idea is, or the finding is, that we can only build a better world, a stable world, a resilient world where the economy can thrive also in the centuries before us, if we base our decisions on scientific evidence and technological innovation. And this is also seen by many people in the United States. But in the United States, half of the population is not believing in science. And so you have this polarization, you have this bipolarity in the community, that if the Democrats say, listen to the science, the Republicans say the science is useless. And this is a cultural thing, actually. And the good thing is that in Europe, this division never really happened.
네. 이제 유럽의 이야기를 들어봤으니까 이제 독일의 이야기를 한번 이제 듣고 싶은데요. 앞서 강연 중에 보여주셨던 이제 슬라이드에 보면 독일의 경우 재생 전기 에너지의 발전 단가가 전 세계에서 가장 비싼 나라로 이렇게 이제 표시가 되어 있는데요. 어떻게 이렇게 이 재생 에너지 이런 발전 단가가 이렇게 높은 수준이어도 어떻게 2045년까지 탄소 중립을 이제 달성한다라고 하는 그런 목표를 갖고 있고, 그렇다라고 하면 이런 재생 에너지가 기존의 석탄이라든가 핵 발전에 비해서 이게 경제적인 이익이 있는 것인지, 그 다음에 이렇게 적극적으로 이런 발전 단가가 높음에도 불구하고 이렇게 적극적으로 대응을 할 수 있는 이러한 시민의 의식이라고 하는 게 도대체 어떻게 이루어진 것이고, 또 이걸 어떻게 실현할 것인지, 바로 이러한 질문을 드리고 싶습니다.
Yeah, this is a set of questions, and it would take a long time to answer them all, actually. You are right. The energy cost or the cost of electricity are, I think, the second highest in Europe, at a very high level. In Italy, they are also very expensive, or in Denmark and so on. But this has a number of reasons. It's not anymore that wind energy or photovoltaics are so expensive when it comes to the generation of electricity. The costs have fallen down below the cost you need to produce power from coal, lignite, and so on. The costs are so high because, for example, we still have the feed-in tariff system, which actually created the renewable energy revolution in the world. You know, the German government, long time ago, introduced the feed-in tariff system, rewarding everybody who is using green electricity, rewarding for 20 years or something. This was taken up when by other countries, in particular China, and started with revolution of photovoltaics and wind energy. Now the German feed-in tariff system is still creating big costs, actually. This will be reformed in the next years, for example, when we have the cost of the distribution of the electricity. So the grid, the national grid, where we have to come down with the cost. But all in all, people are convinced that in the long term, renewable energy will be the cheapest. And actually, if you use it at the local scale, and I'm sure it will happen in 20 years from now, if you build a house somewhere in the countryside or in suburbia or even in the city, energy will come from the sun, from the wind, from geothermal and so on. And you will probably be completely autonomous in your energy supply. And the cost will only be the cost of the initial investment. And so in the end, after we have gone over this cost hill, so to speak, we will actually provide energy for almost nothing. That's the future. But it's always like that. If you are a pioneer in a new technology or in a new market, you have to pay extra costs in the beginning. It will only pay off. That is true for every investment. In the beginning, you have to make this investment. It will cost a lot of money. But in the long term, you will be fine. And actually, you will be the champion in the market. And that is the plan. And hopefully, it will work out.
네. 이제 마무리 이제 질문으로 이제 하나씩 이제 들어가 보고자 하는데요. 이제 오늘날 이 기후 위기에 이런 과학적 증거는 엄청나게 지금 증가를 하고 있음에도 불구하고 실질적으로 우리가 이 탄소 배출을 갖다가 줄이는 이러한 문제들은 그렇게 아주 더디게 지금 일어나고 있잖아요. 이러한 측면에서 오늘날 이런 정책 결정자들이라든가 시민들에게 이 기후 위기에 대응에 심각성을 이게 촉진시키기 위해서는 무엇이 가장 필요하다고 생각하시는지요?
Yeah, it is actually what every politician tells me is that before you can come up with concrete measures, like now in Germany, the new government will want to boost renewable energy by 2030, 80% of the supply. The first stage always is to change the perception and the attitude of the public, really. Politicians will only implement the measure in a democratic society, of course. I'm not talking about authoritarian systems, but in a democracy, you first have to change the public awareness, the public perception, the public willingness for transformation. And that has happened now, in particular in Western Europe now. And Chancellor Merkel told me, first you have to change the discourse, the public discourse, and then politicians will take it up. And, you know, a major ally in our fight against global warming turned out to be the Catholic Church, Pope Francis, for example. I'm a member of the Pontifical Academy of Sciences as well, and the encyclical Laudato Si was published by the Vatican in 2015. I had the honor to sort of announce it and actually to present it to the world in Rome in June 2015, so before the Paris conference, together with Cardinal Turkson. And that was a new narrative, really. It was the narrative about the preservation of creation. And actually, it was supported also by people from the Orthodox Church, by Muslims, by Jewish people, by Buddhists, and so on. And I think if we come up with a new philosophy of what a good life is and what the respect for other living beings and other living creatures requires from us, when you can also change the policy. It never works the other way around. You cannot command actually a new thinking from the parliament or from the ministry. But if we have this change of discourse in society, and you, with your lecture series, contribute to this discourse, of course. So I'm very glad to be part of your series. If we change the attitude of the public, then we can also change the policy.
네, 그다음에 쉘른후버 박사님께서 이제 마지막 그 강연 마지막에 그 유럽 연합 집행위원회에서 하고 있는 뉴 유러피안 그 바우하우스라고 하는 굉장히 그 흥미로운 프로젝트에 대한 그런 설명을 해주셨어요. 우리가 바우하우스 하면 1919년에서 1933년, 그러니까 나치가 그 학교 문을 닫기까지 한 14년 동안 학교 문을 열었는데 오늘날 현대 건축에서 가장 커다란 영향을 미치고 있고 2년 전에 서울에서 바우하우스 전시회를 할 정도로 아직까지도 이 건축을 통해서 우리의 삶에 이제 영향을 미치고 있는 그러한 이제 그 학교인데 바로 이제 이 바우하우스라고 하는 이 이름을 갖고 이제 나무를 열심히 많이 심고 그 다음에 그 나무를 갖고 이렇게 도시를 만들자라고 하는 그 이야기를 이제 해주셨잖아요. 자, 그런데 우리가 이제 도시를 만든다라고 하는 거, 도시라고 하는 거는 그 어떤 이 인구의 밀집도, 다시 말해서 이제 에너지, 그 다음에 뭐 자원, 이러한 이제 밀집도, 정보의 이러한 밀집도를 통해서 이제 효율이 이제 굉장히 이제 높은 시스템인데 그렇다라고 하면 이 건물이 이렇게 높이 올라가야 될 것 같은데 어떻게 나무로다가 이렇게 높이 올릴 수가 있는지 갑자기 그런 어떤 질문이 떠오르네요. 네.
Yeah.
네.
Now I'm glad you're asking me this because we still think modern building is steel and concrete and glass and chemicals and so on, aluminium, etc. Now, the interesting thing is that now we know that we can build 100-story buildings, we can build train stations, we can build bridges, we can build almost everything from organic materials, in particular timber and bamboo. And this was a revolution in the construction sector that happened over the last 30 years or something. And of course, when you talk about building, energy efficiency is very important, that we do not lose the heat, for example, and we are very efficient in our technology, which we use for heating water and so on, things like that. But even more important is that we do not create so many emissions from the construction material itself. With concrete and steel, you have heavy CO2 emissions, whatever you do about it. If you use timber, if you use wood, it's quite the opposite. Actually, if you store the timber for a long time in a building for hundreds of years, you have actually extracted carbon from the atmosphere. And again, to your question, yes, I've talked to many building companies now, and they can build you any shape, any house, any construction, any infrastructure from organic material now. An interesting example is a company from Austria, Wiesner AG. They're just building in Singapore the library for the university. It's a huge timber construction, very beautiful, and it will actually store carbon instead of emit carbon. So I think that's where the future is. We still think the future is big skyscrapers from steel and concrete and everything rectangular. I think organic architecture That's the new frontier of construction.
네, 우리 실렌 박사님 이야기를 들으면서 우리 인간이 문제를 인식을 하고 그리고 그 문제를 인식을 하면 또 해결을 하는 과정에서 정말 엄청나게 새로운 이러한 상상력을 발휘를 할 수 있는 이러한 존재라는 걸 새삼 다시 깨닫게 됩니다. 오늘 마지막 질문이에요. 우리 실렌 박사님께서는 우리 인류에게 가장 절망적인 이런 티핑 포인트를 이제 연구를 하시는 분인데 그러한 측면에서 인류의 미래의 희망은 무엇이라고 생각을 하시는지요?
Yeah, very good question. It has to do precisely what you said. It has to do with fantasy, imagination, and it has to do with unconventional allies. So when we would have had this discussion 10 years ago, you had no Fridays for Future, no youth movement. You had no encyclical by Pope Francis. So in the complex nonlinear system of society, all of a sudden, new allies emerge, actually. And this will also happen in the future. But the biggest source of hope is, as I said, our imagination. But 10 years ago, I also would not have thought that the construction sector, which is in a way the biggest problem in global warming, can be something like the savior, because it can, in the end, if done well, it can actually absorb carbon from the atmosphere. And so we keep on imagining, on visioning, on thinking, and so on. And I'm sure other very important solutions will emerge. If we stop thinking, if we confine our imagination to just a cost-benefit analysis in economic terms, instead of thinking of innovation, then of course we will fail, actually. But our fantasy is saving us, I'm sure. And actually, I can conclude with referring to Albert Einstein, the famous German physicist, actually was using one of his offices in Potsdam for a long time. And he said, the biggest resource of humanity is fantasy. So let's use this resource.
네, 오늘 쉘른후버 박사님의 그러한 강연 또한 대담을 통해서 우리가 많은 것을 배우고 또한 우리 이해를 갖다가 또 넓힐 수 있는 이런 귀한 시간을 우리가 가지게 되었습니다. 그런데 우리 과학이라고 하는 거는 우리가 확실한 만큼 불확실하고 또 기존의 문제를 해결한 만큼 또 새로운 문제를 만들어내는 것이죠. 오늘 쉘런 박사님하고 함께 우리가 나눴던 이러한 이해를 바탕으로 해서 우리가 새로운 그러한 또 문제를 우리가 스스로 또 만들어내고요. 그러한 과정에서 바로 기후 위기를 좀 더 우리가 정교하고 명확하게 이해를 하고 또 해결할 수 있는 이러한 방안을 찾을 수 있는 이러한 귀한 시간으로다가 오늘의 이 시간이 되었다라고 생각을 합니다. 오늘 긴 시간 이렇게 함께 말씀을 나눠주신 쉘른 박사님, 그 다음에 오늘 온라인을 통해서 여기에 참여를 하고 계시는 시청자 여러분들께 감사를 드립니다. 예.
It was a pleasure to give this lecture, and it was a real pleasure to have this dialogue with you. So I hope to see you in life, in presence, physically in South Korea or Europe before long, after we have overcome this corona crisis. So I'm looking forward to meeting you in person. Thank you very much, and I thank everybody who was listening to my lecture. Thank you.